Now, some of you don't faint. You see the fractions, but don't faint. Remember, what's our technique when we have equations with fractions? What do we want to do? We want to eliminate them. How do we eliminate fractions? And it works for any kind of equation. You eliminate fractions by multiplying both sides of the equation by the least common denominator. So let's do that first, and that will create a new system, an equivalent system, equivalent meaning it has the same solution, an equivalent system without the fractions. The least common denominator here in this first equation would be 6, wouldn't it? And actually, that's the least common denominator for the second equation as well. So I'm going to multiply every term by 6. 6 times 5/6 would give me 5. So that gives me 5x. 6 times 1/3 is 2, so that's 2y. And 6 times 4/3, the 3 goes into 6 2 times, and 2 times 4 is 8. I'm having to multiply the 6 times every term. 6 times 2/3, 3 goes into 6 2 times 2 is 4, is going to give me 4x. 6 times 1/2, that's 3. And 6 times 11/6 will be 11. Now, that looks better, doesn't it? Some of you can stop hyperventilating. We now have a system that doesn't have any fractions in it. I have in the y coefficients, I have 1 plus 1 minus. The least common multiple here would be 6. So let's make this coefficient plus 6y, and here we'll make it minus 6y by choosing the right multiplier. To get a 6 from the 2 when I multiply, I'll have to multiply by 3. And here, to make that minus 6y, I multiply by 2. So 3 times 5x is going to give me 15x plus 6y equals 24. 8x minus 6y equals 22. 15x plus 8x is 23x. Those are 0 equals 46. Dividing both sides by 23, I have x equals 2. So now we know that the x value of the ordered pair that solves this equation is 2. We just need to find the y value. Now, where are we going to substitute 2 for x? Are you going to go back here to this original system, going back to one of these equations and put 2 in place of x? No, then we'd have to mess with the fractions, wouldn't we? So we go to one of the equations where we've already removed the fractions and put 2 in for x in one of those equations. Say this equation. If we put 2 in for x, 5 times 2 is 10. We'd have 10 plus 2y equals 8. Subtracting 10 from both sides, 2y equals negative 2. When I divide both sides by 2, I get y equals negative 1. The ordered pair solution for that original system is 2, negative 1. Did I mess with the fractions in that original system? No way. I eliminated them as we always do by multiplying by the least common multiple. Then I solved that new equivalent system. Because any solution to the original system is likewise a solution to this system, and vice versa. Solutions to this system are solutions to that system. That's what we always do when we have equations with fractions. Get rid of them so as to create a newer, simpler equation to work with.